Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our 72nd CoCoRaHS Weather Talk webinar. A very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from Fort Collins, Colorado on here, almost the midway point of October. For those of you who are unable to join us for our live broadcast, we're recording today's talk and it'll be available later this week on our website. All of our Weather Talk webinars are sponsored by generous donations from listeners just like you. Well, today's webinar is on the Accumulated Winter Season Severity Index, known as Aussie. Have you ever thought, wow, this has been quite a winter, but is it really that bad, or is that just something we perceive? We'll explore this very subject shortly. With us today is Barb Boustead. Barb is a meteorologist instructor at the National Weather Service's Warning Decision Training Division. Her Weather Service career also has included 13 years as an operational meteorologist in 2 Weather Service forecast offices, as well as 3 years in National Climate Program leadership. Barb has also served as a CoCoRaHS state and regional coordinator for many years. A North Central Michigan native, Barb earned her undergraduate degrees in meteorology, geography, and English from Central Michigan University. She has an MS in meteorology from Penn State and a PhD in applied climatology from the University of Nebraska. She and CoCoRaHS's Steve Hilberg worked together to develop the Aussie as a component of her PhD work investigating the weather and climate of Laura Ingalls Wilder's book, The Long Winter, the story of the Ingalls family experiences during the winter of 1880 and 1881. Barb is also a writer and is working on an upcoming book that she will tell us more about. Barb serves on the AMS Committee on Environmental Stewardship and is a past member of the AMS Committee on Applied Climatology. She is the past president of the Laura Ingalls Wilder Legacy and Research Association, a 501c3 nonprofit organization. Barb roots for all of the Michigan sports teams, and she loves to look at severe weather, and don't we all? We kind of enjoy that as meteorologists and climatologists out there. Well, let's give a warm welcome to longtime family member of CoCoRaHS, Barb. It's great to have you with us today. So a question I usually ask all of our guests as we start out is, tell us a little bit on how you became interested in weather.
I am one of the people who started out as a child afraid of weather. I remember having thunderstorms when I was about 4 years old, and I was afraid of them, so I'd go knocking on my parents' doors, and my mom and my sister decided to take me to the library to get me some books about the weather so I could learn about it and be a little less afraid of it. And little did they know how well that would take off. So I think we started through those books when I was 4 and got through all of them in the library by the time I was 6 or 7 and started repeating. And one of the lessons I learned in the books was that in a thunderstorm, you're safest in the interior of your house or in the basement. So when it would storm at night, instead of going into a bedroom, I realized it'd be safer if I just put a sleeping bag in the hallway. So thank you for the warm welcome, Henry. And it's really great to be talking to some fellow CoCoRaHS folks. I've been involved with this program a long time, and I just think the world of it. But what I'm going to talk about today is whether we think weather in the winter is awesome or awful, ranking the winter severity with this Accumulated Winter Season Severity Index, or Aussie. And again, I want to point out that this is in collaboration with Steve Hilberg, who is now at CoCoRaHS, and before that was with the Midwestern Regional Climate Center. And he and I were co-developers and co-producers of the Aussie. And maybe this is why Steve and I come at winter weather from different places, right? Steve, if you know Steve Hilberg, he loves winter weather. He lives for it. He waits for it. I could take or leave some winter weather. This is our thoughts on what makes us happy in the wintertime. And me hanging up the shovel makes me pretty happy. But When Steve and I designed the Aussie, what we wanted to do was be able to put a current winter or any given winter into context. So was it a bad winter or an easy one? Oops, I'm sorry, Steve, I'm not going to use judgment words. Was it a mild one or a severe one? And how does the winter compare to others in the past? How does it compare to the winter in other places around the country? We wanted to be able to provide an index that was useful and usable, kind of like the indices that are used for other high impact weather and climate events. There are indices for hurricanes, for tornadoes, for droughts, even for northeastern United States winter storms. So we thought it would be great if we had a winter index too, and especially if we can use this index for all the things we've talked about, also maybe assessing climate variability, looking at how, for example, El Nino and La Nina affect winters, and climate change too. So for me, though, I came at this, as Henry said, from a bit of a different place, and it was to answer this very specific research question. The book, The Long Winter, is by Ingalls Wilder. Many folks who grew up in especially the central United States at least grew up hearing about Ingalls Wilder or watching Little House on the Prairie. And in her book, The Long Winter, she described in great detail the long, cold, snowy winter of 1880 to 1881, where she lived in De Smet. It was Dakota Territory at the time. It's now South Dakota. So as I took on the research project to investigate that winter, I wanted to be able to quantify how severe that winter was. You know, was it really severe? Was it as severe as she described it? Or is this, you know, grandma recalling a winter from long ago and how she walked uphill both ways in 5 feet of snow? If it was severe, was it like the most severe? Is there a comparable severe winter? Was it severe in a lot of places that winter, or was it pretty local to their area? There just were a lot of questions about it. And so in order to answer these questions, we had to have an objective way to compare the winters.
Barb, where is that picture with the train from? Is that in that area or is that somewhere else?
I'm sorry, I should have captioned that. That was in Sleepy Eye, Minnesota, which is in southwest Minnesota. And that actually was a picture from March of 1881 where the trains were snowed in. And this is the continued efforts to try to loosen up the tracks and get trains to be able to flow. I will talk a little bit more in a little bit about how long it took, but it was months before the trains would actually start running through again. So more specifically, here were our goals for Aussie. The first goal we had is that it had to use widely available data. So in our case, Aussie is based on daily readings of temperature, snowfall, and snow depth. And we also have a research version that uses precipitation instead of snow. We wanted to be able to create an Aussie database or Aussie information for any site that has daily records. That could be a co-op site, a first order station, anywhere that takes both temperature and snowfall and snow depth. Next, we wanted it to be objective, that we could use as a baseline to scale the subjective impacts. So we wanted it to be hard data underneath it, and then use that as a basis for comparison for anything from transportation costs to school shutdowns to commerce and so on. We didn't want to include subjective information into the index though. Next, we wanted this index to accumulate value as the season progresses. So as you start the winter, you start at a 0. As you get wintry conditions, this index increases through the winter, and then you get one number at the end of winter that gives a meaningful representation of the total severity of that winter. The index had to let us make comparisons in some way. We have to be able to compare year to year at a site. We also wanted to be able to compare site to site in any given year. We want to be able to look at groupings of sites in a year to gauge relative severity over space and look at the historical climatology to gauge relative severity over time. And finally, we did want the index to be able to be applied to multiple users and their needs. It does use objective data as a baseline, so that they can use that to pair it with data that matters to them and look for relationships. So for example, it might help understand year-to-year differences in the cost of maintaining roads in winter, or certain animal migration patterns, or the emergence of some vegetation, among other things. So let's go over just some of the basics of how we calculate AWSSI. AWSSI is a site-based index, so it's calculated at the observing site with the available temperature and snow data. There are 4 basic ingredients that go into the AWSSI calculation: the daily maximum temperature, the daily minimum temperature, daily snowfall, and daily snow depth. Each of these ingredients is assigned a point total for that day, and then all of those are added up to create a daily score, if you want to call it a score. Then each day's score is added up through the season to get that season total at the end for that location. The points are assigned based on thresholds that we created. The thresholds are somewhat arbitrary, but they did have intent in their design. So for example, with snowfall, we did want to be sure that a 6-inch snow that falls in one day has the same value as a 6-inch snow that falls as 4 inches one day and 2 inches the next day. And that's because a lot of our snow events cross over the observation time, and it's really one event. It just shows up in 2 days. Also, you'll notice the temperatures are in 5-degree bins, but we gave extreme cold temperature readings exceptionally large point totals. We also did that for extreme snow depth and extreme snowfall. And I also should note that we apply quality control to the data, and years that have more than 5 missing temperature or snow records are omitted from the records. Sometimes those missing days don't have a lot of points to them, but sometimes they do, and we just don't have a way of knowing, especially historically, what was in those missing days. So if we don't have complete data records, we can't give a reliable climatology for the site. Now, how to define the beginning and the end of winter accumulation was a matter of some debate. And so let me pause and ask you to think about it for a moment. How does winter begin in your mind? What's the trigger to say, yep, winter has begun now? We took to some informal polling and learned how folks defined it for themselves, and we got a range of answers. For some people, it was the calendar, December 1st, that's the start of winter, or the winter solstice. Some people, it was more of how it feels out there, when I have to wear a coat, a winter coat, or when I have to shovel snow for the first time. So as we tried to figure out how to define the start of winter, we did want to keep the definition objective, sticking with that overall goal of having this be objective data and analysis. But what we took from the feedback is that the calendar matters, and so does that sensible weather. So for us to define the beginning of winter, the AWSSI begins accumulating when the maximum temperature stays below freezing for the first time, or when the first measurable snow falls. And if neither of these happens before December 1st, then we start the accumulation on December 1st. We invert that in the spring to get out of the winter. So we stop accumulating after the latest of these things, when the temperature stays above freezing, after the last measurable snow, or after the last measurable snowpack melts off. And if all of those things happen before March 1st, then we cease accumulation on March 1st. It's interesting, and you might have been able to deduce this as I talked through it, but you might not know that winter accumulation truly has ended for a while. You can envision a site, for example, that has a below freezing day on March 3rd, then a large gap in having any wintry conditions, but then they get a late season snowfall on April 15th. And if that happens, AWSSI will be recalculated, and anything that happened between March 3rd and April 15th, mainly that would be minimum temperatures going below freezing, any of that would recalculate and accumulate up till that snow melts off again. And I want to credit Brian Brettschneider for creating this map a few years ago. He created the map of the average beginning date for winter using the AWSSI definition for an average period of 1980 to 2014. So on average, you can see that the onset of winter by right about now in you can see the onset of winter is there right about now in the Rockies and up in Canada and Alaska. It's that second darkest shade of green. By the end of October, the first winter conditions are observed on average across pretty much all of the Rockies, a good part of the northern high plains into the northern plains and the northern Great Lakes. So it's fairly average, or one might say normal, for winter conditions to already be beginning in parts of our living areas. Because we rely on widely available daily data, there is some impactful wintry weather that is not included in the Aussie. We can't explicitly include freezing rain because we don't archive or measure freezing rain in our daily data, unfortunately. We don't explicitly account for mixed precipitation except as it's measured in a daily snow total. So we don't specifically say have a sleet parameter because sleet isn't differentiated from snow in daily observations. Wind is not a daily parameter either, and we know it can cause significant impacts both with blowing snow and as well as with wind chills. So it's an important component of winter, and we realize that, but unfortunately there's just no way to discern it on a daily basis because even if you had, say, a daily maximum gust, you don't know if that happened in coincidence with the warmer temperatures or the colder temperatures of the day. And you also don't know if there was blowing snow observed just by the data. And then we don't include freezing fog, icy roads, snowmelt that refreezes on the roads, because we consider those to be more of impact parameters anyway, and also because they're not a part of that daily data record that we can download from a climate site. So at each site, and I'm showing Denver here, Stapleton Airport as an example, at each site, Aussie is divided into categories by the percentiles. The lowest 20th percentile of years are considered mild. The highest 20th percentile of years are considered extreme. The mild are red, the extreme are purple. And in between, the percentiles are in chunks of 20s and are labeled moderate, average, and severe. For each year, the site is ranked based on the period of record and where it falls in the percentiles in that record. Now, what's considered to be extreme in somewhere like Atlanta has quite a bit less snow and cold than an extreme year in Duluth. In fact, it's probably less snow and cold than a mild year in Duluth. But everything is relative by site, and it takes far less snow and cold to create devastating and costly impacts in a place like Atlanta. So even though us up north folks might chuckle a bit at what qualifies as an extreme winter down south, it is important to remember that the impacts of winter are different from place to place, and the ability to handle it as a society is different too. So by creating a site climatology, we're normalizing to that site, which actually better lets us compare apples to apples across the country for a winter season. These percentiles are calculated for every day through the winter season also. And we're going to take a look at this chart in another way in just a moment, but we'll show you how it looks a little bit for some complete winters too. So let's take a closer look now at how the Aussie totals and categories are displayed. And all of these are available on a website hosted by the Midwestern Regional Climate Center, or MRCC, and thanks to them for hosting this. The Aussie data on the MRCC website are updated daily during the winter season, or when the first sites begin to activate their winter seasons. It's usually around this time of year that the MRCC refreshes the page and starts the next year's accumulations. It is a zoomable map, and it displays color-coded dots or diamonds for each site where Aussie is calculated. You can see the 5 categories of severity from mild to extreme, and diamonds indicate a record mild or record extreme, depending on what color they are. So the map really lets you see the overall pattern for a winter, where it has been mild or severe. The one I'm showing in this example is last winter's ending accumulation. And you can see that there was a lot of record mild to mild weather across the eastern half of the United States. And if you wanted to find severe or extreme winter conditions, you really had to go north, well north in the United States, to the UP of Michigan, to North Dakota, and maybe into Wyoming to find those more wintry winter conditions. The categories are shown on this map for the winter to date. So for example, a site could rank as a severe one in January if they have, some fairly harsh conditions early in the winter. But if those snows happen to end early and get cut off and temperatures get unusually warm in February and March, it actually could end the year in the average or mild category. Because the average would keep climbing, but if their accumulation did not, they would fall down in the rankings. You can also see near the bottom of the page that you can have access to the end of season summaries for past years if you select a season. And those go back to 1950 to 1951, the first year of Aussie calculation that we ran backwards. And again, they'll be available for years that were not omitted due to quality control. And you can download a CSV file with the data at each of those sites too. And the website is displayed here. I know it's a long one, so if you just go to Google and Google, you can put in MRCC Aussie, that will get you there.
Barb, we can add this to the resource part on the web page. Each broadcast has a specific page, and we'll put that at the bottom.
Perfect, Henry. Thank you. Now, if you click on any of those dots for any of the sites on the US map, you'll see the accumulation chart that looks like this, the one I just showed you. And again, this is for Denver. And you can see there is a rainbow of colors, and that entire rainbow encompasses the envelope of past winter conditions on each day of winter, from the least to the most severe. So if you have a line being drawn that's going above the purple or below the red, that means you're setting records in the year that you're in. And it shows the ranges in each of the 5 categories too. It won't work on a PowerPoint slide, but if you mouse over on the actual website, you'll see where the percentile rankings are and what the value is of the day for any day of the record. The interface lets you choose to display the current season, and you can also display any historical season from 1950 to 51 to the previous year. You can also choose to display the 5 or 10 most recent seasons and the 5 or 10 years that are closest to the current to-date Aussie score. So for this example in Denver, and I actually picked up this example about 10 days ago because I wanted to show what should winter be like if you've had a very early season snowfall. Some of you might remember that there was an unseasonably early accumulating snow in Denver. It was in early September, I believe September 8th and 9th. So, a question that might come to mind is, well, is that a harbinger of a severe winter to come? And so I posted the years with a similar score to date as of October 6th. And you can see that years that started similarly really have a pretty wide range of where they end up. Some of them ended up being moderate, and I guess they ranged up to about the low side of severe. So in other words, an early season snow in Colorado really doesn't tell us all that much about the winter to come. Credit back to Dr. Brian Brettschneider again, who created this map. And this is the average Aussie score for the years 1980 to 2014. So it gives us something of a climatology or an average or normal across the United States. One thing that Steve and I noticed as we did the research for the index is that areas that have a similar total for winter on average don't necessarily have the same types of winters. So for example, over the eastern Great Lakes toward the northeast, the winters there tend to be pretty balanced between temperature and snowfall contributions to the Aussie. But as you go further west, for example, over the plains, the temperatures really become more dominant with lower snowfall totals. And also interestingly, that the Rocky Mountain areas like Denver and Cheyenne have longer winters. But they have a lot more milder breaks in the middle. So they end up with a total that's pretty similar. But again, it's a different character of the winter. So now can we look at all of these winters from long ago? Well, official observing sites began taking snowfall and snow depth measurements around the year 1948. There are a few sites that have some earlier readings, but the widespread data are really only about half a century, well, I guess 70 years or so old. We wanted to look farther back than that, if you can recall, all the way back to 1880 to 1881. So for our research purposes, we also derived a version of the Aussie that uses temperature and precipitation data to calculate basically an approximation of snowfall that then we can plug into the Aussie. So very roughly, if the temperatures were below freezing and precipitation fell, we could use a calculation to estimate how much snow fell from that. And we accounted for sort of the milder below freezing temperatures and the very cold below freezing temperatures, and also for light, moderate, or heavy precipitation. And the formulas that we used, we applied here. And you can see, if you look at these curves, it actually did a pretty decent job estimating snowfall and thus estimating the Aussie. These are long histories for Minneapolis, St. Paul in the orange and Urbana, Illinois in the teal color. The solid lines are the traditional Aussie and the dashed lines are the recalculated version using precipitation data. And there are a few spots that are a little different, but you can see that the calculation does capture the character of the winters from year to year at both sites. So it didn't do too bad. For those who are statistics junkies, our R squared was 0.93 for both, meaning that correspondence is pretty high. Now, it's imperfect to be sure. We're only using daily highs and lows and daily precipitation totals. So we don't know what the temperature was exactly when the precipitation fell. We sometimes can't tell the difference between the days that would have produced snow and those that produce freezing rain, although it might be a side benefit here that probably we included some freezing rain events into the score. Also, for some reason, this formula just doesn't work as well in the warmer lake effect type climatologies like Buffalo, for example. It tends to overestimate the snow in there, and also in general in mild temperature, heavy precipitation type events. But all of that said, that was a close correlation that made us pretty happy. And we thought certainly a close enough correlation to be useful for our research. So finally, then, we can circle back to this original research question. Was the long winter of 1880 to 1881 the most extreme on record in the areas around eastern South Dakota where Laura Ingalls Wilder lived? Well, let's take a couple minutes, and I'm actually going to talk a little bit more about the things that happened during this winter and why it was at least the story of such a severe winter. Because not everybody listening to this may have read the book, The Long Winter. So the winter began on October 15th to 18th, 1880, when a blizzard struck parts of South Dakota, Nebraska, Iowa, and Minnesota, that area where all those states are adjacent. We know that a blizzard struck on those dates because we can actually use historical weather maps and the historical observations that are kind of in the area to tease it out. And Laura also, interestingly, in her manuscript, was pretty precise about that date too. I believe her draft manuscript before the published version actually had the date October 15th in it.
So how apropos that today is October 15th for this webinar.
It couldn't be more perfect.
How about that? Yeah. Go.
So when they endured that October blizzard, the Ingalls family, Laura's family, realized that their little claim shanty was not going to be a substantial enough shelter for the winter. And they moved into town. Now, starting around mid-November or so, the snows returned and it got pretty chilly. There were some cold outbreaks too. And by December, substantial snows or probably blizzards began to impact the area. So Laura described in the book an episode in which a blizzard strikes while she and her sister Carrie are at school. The students and teachers struggle to make their way back to their homes in town. It's a little bit reminiscent of David Laskin's book, The Children's Blizzard, which is about the blizzard of January 1888. Luckily for these students, they did make it home. But it was a similarly chilling type of tale, no pun intended. Laura also describes a blizzard that strikes in the evening on Christmas Day, which also bears itself out in the data records that are available around that time. Now, by then, the repeated blizzards already had impeded those trains that were so vital to the area. And the trains ceased operations into the area. Now, why was that such a big deal? Many of the towns, including De Smet, that were along the tracks, were new just that year, or maybe some of them had been established or only a year or two before. A lot of the folks who had moved out to the area were new too. And when you move out into homesteading that first year, you don't have time to do much or gather much. You sort of bring what you can, you grow what few things you can, rely on supplies to come in through that winter and really get things started the next year. Well, unfortunately, folks didn't have that chance to do very much as far as gathering and keeping supplies or really making their shelters more substantial before this winter struck. So they really had been depending on the trains to keep running to bring them food supplies and fuel supplies. And it isn't like there's a bunch of trees to burn in South Dakota once you run out of coal. But the trains impeded the supplies and the residents were left to make do with what they had. The trains were shut down across the area by around the first week in January. And the snow and cold and wind continued with a 6-week stretch in the data records from mid-January through the end of February, in which snow was reported in at least one site somewhere from central South Dakota to central Iowa on all but just a few days. So that's 6 weeks that it was snowing somewhere all the time. The snows became a little less frequent in March through early April, and a couple days even poked a little bit above freezing, but the wintry weather just kept coming back. It was kind of the worst of teaser weather, probably, by the time they had gotten to that point. And then again, with a date that's very singular and just like a switch, it was April 13th to 15th, depending on where in that small region. It's like a switch flipped. Laura described in the long winter hearing the Chinook winds blow. Those are sometimes called snow eater winds, and for good reason. It's a wind that is very conducive to snow melting and evaporating. So just like that, temperatures warmed above freezing that day, and the maximum temperature never fell below freezing again. The minimum temperatures never fell below freezing either after about April 20th to 22nd. So what was likely a record snowpack had fallen across a wide swath of the north central US through that winter. And although this particular component doesn't make it into Laura's book, the sudden warming caused massive flooding, ice jam flooding initially, and then just snowmelt flooding that continued well into the summer of 1881. But was it the worst ever? I'm sorry, I don't mean worst, Steve. The most extreme ever? Maybe, kind of. It's at least in the top 3 to top 5 around much of the northern and central United States. De Smet is marked here with a green dot. There is no observational history there in De Smet, but it's marked there for reference. From Montana to Kansas over to Iowa, there were a few sites that did report the most extreme winter on record. Those are those diamond-shaped purple markers. But for South Dakota, we just don't know. We don't have the data that is continuous that far back to the present. Certainly what we do have and is enough indication that it was very extreme winter at the least. Minneapolis, St. Paul is an interesting bear. The snowfall component of Aussie was by far the most extreme on record, but the temperature contribution to it wasn't. So it ends up not being the most severe on record there. Well, that brings up another interesting question. Okay, if it wasn't maybe the most extreme in that area, or certainly in adjacent areas, then what was? We're displaying
Can you
here.
go back to what were those numbers on there next to the?
Oh,
yeah. What are
yeah,
those different numbers?
The numbers are the Aussie total score for the year. So you could compare this to the map like Brian Brett Schneider's a few slides ago that shows what an average for 1980 to 2014 looks like. Because keep in mind, this when we run the Aussie, we run a score that counts up all through the winter. So it's a little out of context to show it without the full range there, but that shows what their total score was for that winter.
Thank you.
Sure. And what we're displaying on this one is the year that was the record. So there are some clusters that emerge on this map of the most extreme winters in our research area. And that 1880 to 1881 there is circled again. From North Dakota to Lower Michigan, the winter of 1874 to 1875 wins the award for most extreme. Now, what's interesting about that is at that time, the Ingalls family lived in Walnut Grove, Minnesota during that winter. And that's about halfway between De Smet and Minneapolis, St. Paul. So it's right in the area that probably was the most extreme on record there. So why wasn't that the long winter that she wrote about? I have some ideas on that, but we'll get to that another time. You can also see, by the way, those of you who are in parts of the Midwest and actually might remember these, the winter of 1977 to 1978 did set the record in some parts of the Midwest there. Probably the most recent record extreme was the winter of 2013 to 2014, which was particularly severe in the upper Midwest, but Marquette set a record. By and large, though, all of these most extreme winters happened quite a while ago. Which brings us to another point, that one thing that we noticed as we went through these records is that it's getting harder and harder to get winters to those historically extreme levels as we go on in time. I'm showing an example here from Detroit. And you can see that early in the record, these very extreme winters used to happen once or twice per decade, especially in the 1870s to 1880s. Then they started spreading out, maybe a decade or decades in between, 1904, 1912. Then they became once per generation to once in a lifetime events. So when a winter like 2013 to 2014 happened there, which was a very extreme one, it wasn't that it's unprecedented, but most people living and working there haven't lived through one like it before. So Aussie is not a perfect measure for climate change. It can, however, show some of the impacts of climate change on how extreme our winters can get and how often they can get there, what our winters used to be compared to what they are now. So a final reminder here to keep an eye on the MRCC Aussie page this year, bookmark it, come back to it, and track the progress of your winter. See if it matches your perspective. For those folks in the East, I can tell you that folks who have had a very mild winter, if they have even an average type of winter the next year, they tend to feel like it's a harder winter. If you had an extreme winter last year, an average one might feel pretty mild. So it's interesting to see if your perspective on how the winter is going matches where the numbers will show you. And if you're interested in more information about this unique intersection of weather and climate with Laura Ingalls Wilder, I've dubbed this Wilder Weather. I do have a few links and resources for you. The blog isn't very frequently updated now, but there are some articles there that are still shown, and they have information about some of the past weather events in Laura's books. The Medium site is where I'll probably post newer things now. And that does include a fun little article on the 10 lessons from Laura Ingalls Wilder that were helping me cope with quarantine. And then I have a Wilder Weather Facebook group that you can join, and you can ask questions there. I'm interacting on it. And if you're more interested in the scholarly side, the data and numbers, the long winter of 1880 to 1881 just came out in the Bulletin of the American Meteorological Society. And finally, I'm going to put in a plug for my friend Cindy Wilson's book, The Beautiful Snow. It is about the winter of 1880 to 1881, and she's also a Laura Ingalls Wilder fan and colleague. And so she comes at studying this winter from a different perspective from me. And she has a clear interest in the weather side, but she comes at it from the perspective of what happened to the trains, and she sources it really heavily from newspaper articles of the time. So it's a very interesting resource too. And finally, we do continue to work on things with the Aussie here and there. And I know the Midwestern Regional Climate Center continues to improve and tweak the web and data display. So we have investigated some capabilities like using climate models to project the range of severity of the winter, maybe 2 to 4 weeks ahead. We do continue to try to research with it, and we continue to get folks who are using the data and telling us how in all these interesting ways. So if that applies to you in any of those, you're certainly welcome to contact us and let us know if you're using it, or let us know if you have perspectives on it. And otherwise, thank you for listening to this presentation, and I look forward to any questions or hearing from you later. Thank you.
Barb, thank you very much for taking time out of your busy day to give this fascinating stuff. The links on the slide before We will put those on the web page as well, so you guys can follow up with those. We'll have that listed if any of you all are interested in that. Well, we're going to take some time for questions now. And so if you would, when you type in your question, type in your state, where you're from. That way we kind of get an idea of where around the country some of these questions are coming from. An interesting thing I was reading about, speaking of winter, this morning in the Wall Street Journal was an article that a lot of the Canadian snowbirds who love to come down to Arizona and Florida this year will not be able to do so because they cannot cross the border. So they will be enduring the winters up in Canada. So for you folks in Canada, that is that could be a tricky thing this year. Some of the things that people were saying was that they didn't have, they got rid of all their sweaters and stuff, and others had bought mobile homes and that were not insulated to withstand a winter, that they made that their full-time place. So interesting stuff as we think about winter. Well, I've got a couple questions coming in. Barb, you ready? You're ready for a few?
I'm ready. Let's go.
Okay, Dennis wants to know, how do we get more stations calculated? Who do we contact? And Dennis is from Oregon.
Hi, Dennis in Oregon. That's a great question. Those have to be manually added by Steve and folks at MRCC. You can reach out to our email addresses if you want to talk about getting sites added. The sites have to have a long period of record, and they have to pass certain quality control rigor. So if they make those benchmarks, then it's something we can look into. It's not the fastest process, but it is possible.
Thank you. John in North Carolina said also, if you could just remind people, you mentioned the GHCN. What does that stand for? Just to let folks know.
That is the Global Historical Climate Network. GHCN data are considered to be the most reliable and long-lasting of our observing sites.
Okay, great. Charles wants to know if the analysis, the Aussie analysis, can go back to examine the era of the Donner Party back in 1846 and 47.
Oh, that would be fascinating, wouldn't it? Now, I don't know of any observed data at the time in that area. In fact, I don't know of it really in any area. That would be really fascinating, though.
Okay.
I think what you could do in lieu of that, there is some model reanalysis data that can look at winters back into the earlier 1800s, and that data might at least give you a glimpse at the weather patterns and if it was a cold pattern or a snowy pattern.
So Maggie from Massachusetts writes, she says, in the long winter, Native American warned the Ingalls family that it would be a very severe winter. What markers or events would have informed the knowledge of what was to come? And she thanks you for the answer.
That is a question I get quite a bit. There is no evidence that there was a Native American who came and warned the town. And in fact, it doesn't appear in an earlier draft of the book, which leads me to think it was one of the parts of her books that were fictionalized. But still, that folklore, that, why, of all the things to say, why is it that she said every 7 years is a harsh winter and every third 7 years is an especially harsh winter? Was that legend up there? Was it folklore? Was it something the settlers said to each other? Or was it in some version of a Native American communication that I haven't uncovered in the records, or folks haven't uncovered in the records yet? A lot of people who read The Long Winter as a kid and found out that it was actually a winter and it happened in 1880 to 1881, would then go on and count by sevens to see if this winter that was coming was supposed to be one of the every 7 winters. All in all, I'm going to go on the presumption that probably didn't happen like Laura described it, but that there may have been some recognition of some kind of a variability in the patterns. And in my mind, it's possible they were picking up on perhaps an ENSO signal. And now, El Nino and La Nina collectively is known as the ENSO cycle. And that happens around every 3 to 7 years, roughly. It's not an even cycle. You can go many years without a La Nina, many years without an El Nino, but there is certainly that year-to-year variability. And that cycle may have been picked up by folks who lived there long enough and realized that they might go some years with milder winters and then have some years with harsher ones. In the winter, by the way, of 1880 to 81, there was a strongly negative North Atlantic oscillation pattern, which is very strongly correlated to cold weather in at least the eastern and central United States, sometimes the western US too. And it was combined with a mild El Nino. Now, El Nino often is tied to maybe tipping the odds a little bit toward a warmer than normal winter in the northern plains. But for some reason, when you combine a very strongly negative North Atlantic oscillation with an El Nino, this has only happened a handful of times in our records, but the handful of times that it did were almost universally cold and snowy winters in the northern plains. And a good recent example of that was the winter of 2009 to 2010. So that's a very long-winded answer to say, I don't know if the Native American exists, and I don't know if that 7-year thing is real, but if it is, it may have been capturing seasonal variability like El Nino and La Nina, or like the North Atlantic oscillation.
Okay, thanks for that answer. Here's Gail from Arizona, and Gail says, little house convinced me to move to the desert Southwest. She says, do you collaborate with the National Phenology Network or similar organizations?
I certainly am aware of their work. I don't know if their records have the kind of link that I would want. I think you could probably put the two data sources together, the Aussie and the Phenology Network, and find some relationships. I don't know that anybody has done it, but for those who are looking for maybe master's student projects, that might be a very interesting one.
Okay, and Jackie from New Mexico was just want to point out that severity can mean temperatures too high, such as insufficient snow and moisture. Have you guys considered that?
When we rank, well, that's we rank from mild to severe so that we don't use that kind of judgment language like good, bad, hard, easy, because a mild winter can have negative impacts too. And a mild winter can have negative impacts on, for example, trees that require a certain number of chilling hours in order to produce their fruits the next spring, or the recreation industries like skiing, for example. And yes, that too is an example of how a mild winter doesn't necessarily mean it's a good winter.
Thanks. Brenda here is just saying she's in Southwest Kentucky, and she's got a brother who lives in Fargo, North Dakota, and she will definitely share this information with her family there. Thank you, Brenda, for that comment. Here's Curtis in Nashville, Tennessee. He's preparing a presentation for his church on climate change. He was wondering what website would he use to compare severe versus mild winters over time for Middle Tennessee.
If you go into the Aussie website that is going to be linked here, you can pick a site that's as close to you as you can get and look at its past winters. It's a little tricky to look at any one point because the real story of climate change is in the collection of points. So you can certainly look at what's happening near you, but I'd encourage you to look around at what's going on in a bigger picture. And Aussie can help tell that story a little bit, but I think you're probably going to find better information to help tell that story through perhaps the national NCEI, National Centers for Environmental Information, or climate.gov, some of those sites.
Okay, here's one from Andrew. He's lived in the UK, Montreal, and Boulder. His perception of winter severity would include wind chill, humidity, and cloudiness. He understands the difficulty of including this, but he was just curious about any possibilities of that.
Unfortunately, there's no like standing database of wind chill or of humidity or of cloudiness. You can go back into the data and discern it. It requires a lot of data mining, and you'd have to keep it up yourself too. But there's no central repository of that information that's continually updated, which is what makes it so challenging to use. Somebody could go through all of the hourly sites and calculate hourly wind chill and come up with a coldest wind chill of the day and create a database for it. And if somebody did all of that, it would be wonderful. But doing that and then the upkeep of keeping on doing it so that it stays fresh is a big workload. It's why a lot of that stuff doesn't exist even on our government sites, because it's very time and labor intensive to come up with climatologies like that. So I totally get, like, it isn't a complete story of winter without the winds. And I think it would be a great addition if there was that capability in the future. But until there is, the logistics just make it too challenging.
Okay, John writes that he may have missed this. So if you could answer this question again, but does snowfall or cold temperature have a larger bearing on the index in a typical winter? And he says he can live with the snow, but hates the cold. He's in Minnesota.
So it depends on where you live, actually. There are certain climatologies, those plains, Great Plains, Central Plains, Northern Plains areas that tend to be cold and dry, compared to, say, the Northern Great Lakes or over toward New England, where the cold and temperatures may have a more balanced contribution to the Aussie. So if you're seeking, like, you don't mind the snow, but you want to be a little less cold, I think you've got to move east. You probably have to go to, like, upstate New York or Vermont or something like that.
Okay, great. Penny was asking that, I guess she's participated in before, she said the severe weather tab was not working on the website. She's been last 2 years with rain snow mix. She combined that with the snow and daily total and made a note of the freezing rain. So maybe we could follow up with her afterwards on that question. Okay. And Rod is now he's asking you to go out on a limb to try to make a prediction. Now maybe you may not want to make a prediction or might not be able to, but could show him where he could find out some information. So how about a prediction regarding this upcoming winter for the Western Upper Great Lakes region?
Oh, you're going to challenge me. The Climate Prediction Center's outlooks were released just today, and I'm afraid I should have and did not look at them. But going into a La Nina winter, we generally expect that the northern US is probably going to show in the maps they produce to have a higher than usual chance to be colder than normal. And the southern plains will probably be on the maps with a higher than usual chance to be warmer and drier than normal. Let me take a peek. I just got it up. Yeah. Yep, that's pretty consistent.
Okay, thanks. Birdie, she writes in and wants to know, is there a correlation with sunspots in solar activity to winter severity?
Not so much, unfortunately. Sunspots do affect some sort of very low underlying conditions, but it's not enough impact to measure in winter impacts.
Okay. Blaine from Indiana was wondering, last few years, the Weather Channel has been naming winter storms as if they were hurricanes. Was wondering your thoughts on that.
I plead the fifth.
Okay, very good.
I'm a federal employee. We do not, as an agency, name winter storms.
Gotcha. Okay, here's one from Dennis from Oregon again. He's at a second question. He says the painting of The Last of the 5,000 by Charlie Russell was a painting for severe winter in 1886-87 showing the cattle devastation in Montana. It would be interesting to see how it stacked up to other winters. And I guess that's more of a comment he's got on that one.
It's question-ish. All of the 1880s, with the exception of the winter of 1881 to 82, it was kind of nice. The winter of 1881 to 82, the one that immediately followed the long winter, was quite mild in the area. They probably needed that. But the rest of the 1880s, basically the entire decade had cold and fairly snowy winters. All of their winters rank pretty low, except for that one I mentioned. So there were several winters during the 1880s that were particularly harsh, particularly toward the extreme side of the scale. And I know that 1880 to 1881 is one of them. 1887 to 88 is another one. 83, 84, 84, 85. I wouldn't be surprised if 86, 87 is in there too. And some of the winters that I read about there had extreme cattle die-offs. The long winter interestingly, was not that fatal to humans, especially later in the winter. People kind of figured out it was a harsh winter and stayed in and weren't exposed to the elements, but it was terrible for the cattle impacts. There were fairly widespread livestock losses. And from what I have read from some resources, at least part of that is because earlier in the winter, there was some version of an ice storm that put an ice covering on a relatively bare ground. And it stayed cold enough that that never really melted off. So cattle had trouble. They couldn't just dig through the snow to get to the grasses because the grasses were under the ice. So I think that happened probably a couple of times in the 1880s. And that may have been the case in the winter you mentioned as well.
Here's one from Cindy in New York, and she was wondering if you can explain again about what you meant about measuring how long it stays above or below freezing in your calculations of the Aussie index. Example, how long does it has to stay below freezing before you start calculating for the beginning of winter?
Sure. The minimum temperature of the day has to record below freezing. Or sorry, the maximum temperature of the day has to record below freezing for it to score a point. So that is something that is calculated from the hourly data, and that's based on the coldest temperature measured during that hour in, I believe, a 1 minute interval. So basically a minute.
Mark brings up the year without a summer, 1816, and was wondering if there's any regressions going back that far.
Unfortunately, no. I'm sure that one would have been way down there on the list too. Well, maybe though, because the most notable impacts of that year without a summer, which was at 1811 to 12 or whatever it was that it was cold during the summer, right? So
Right, yeah.
at some point the Aussie would have ceased its accumulation, and then it's very unusually cold. It's definitely a high impact, but it's not a winter per se. So I don't know if it would have measured much differently on the Aussie, but it certainly on a yearly average would have.
Here's one from Pennsylvania. Would this scale be more useful to compare specific time parameters? And they've got in parentheses NDJ, well, it's November, December, January, February, March, not just the first winter qualifying event to the last qualifying event. Thoughts on that?
That absolutely would be a useful way to break down the data. And I believe we did that for some of our analyses too. You can, the data will accumulate for a total season, but you can take any chunk of it to examine a relevant period if you want to look at a certain period that you think is of importance in your area or to your concerns.
We've got two more questions, and we'll finish up with these. Pat mentions that they moved to their location in the fall of 2008. On December 3rd, it began snowing and continues until December 29th for a total of 9 feet. Since that time, we've had much less annual snow here. How do you look at that historically?
Boy, that's interesting. Where did you say you were located?
He didn't give a location. Pat, can you type in your location for a second?
I mean, and more generally, in the meantime, the Aussie accumulates for a full season, and that full season total would certainly include a huge bump from such a large December snowfall. Year to year, if you were just looking at the yearly totals, it wouldn't differentiate it much from a year that had, say, a big January or a big January through March, or spread whatever accumulation that was out through a longer period of time. So that might actually be another interesting year to look at just the Decembers and their accumulations of Aussie.
Oh, he's in Diamond Lake, 23 miles north of Spokane, Washington, outside of Newport. Okay.
I thought it had to be close to mountains.
All right. So our last question comes from our very own founder, Nolan Duskin. And yeah, Nolan he says that not all snowfall data are of good quality and consistent over time. How much of an impact would measurement inconsistencies have on computed index values? What would be a big deal or just in the noise?
As I would expect from Nolan, that is an excellent question. The thresholds that we set are fairly broad. And because those are broad thresholds, instead of using direct values, it gives us some leniency in the measurements. For instance, it doesn't matter all that much if it was 1.2 or 0.8. And especially over time, if, someone's an inch or two off or a couple inches off in an otherwise relatively snowy location, there's a lot of forgiveness in those thresholds. Steve and I had a lot of discussions about this actually when we were making the index, that snow is messy. The data it's sausage, right? You don't want to know what goes into it. You're just hoping to use the end product. So we thought that having that leniency that's built into the thresholds would forgive some of those measurement difficulties and errors and inconsistencies through the years. We also thought that if there had been major inconsistencies, that using the precipitation calculated version would draw those out, and we would see that, the snowfall and the precipitation were not working together well, and would be able to investigate why. So having that precipitation calculation to fall back on is helpful, because precipitation is generally a little more reliable of a measurement.
Okay,
Henry,
well,
sorry,
yeah.
this is Noah here. I actually have one more question that came
go
in
ahead. Sure.
from Nolan, and Barb, possibly to put you on the spot, so you can say no if not, but related to Nolan's question, he's wondering how the winter of 2010 to 2011 stacks up in the upper Missouri. And I'm wondering, since we're looking at your screen, is there a way you could even just show us the map and clicking on the dot and showing us maybe how you would answer that question for someone who's using the website?
Yep, give me just a moment here. You're seeing my background, I think.
Sure, and I totally did put you on the spot, so I apologize on this, but I thought it would be something that our attendees would like to see once they have access, once they have the link to the map.
Is that Laura Ingalls Wilder's house here? That picture? No, can't be.
No, but it is.
No.
It's a Colorado site, actually.
Oh, okay.
It's Last Chance Colorado.
Ah, that was the last chance.
Whoops. Sorry about that. I'm zooming myself. Okay, when I meant to scroll down. It was 2010 to 11 you wanted to see? And
yes, 2010, 2011 for the for upper Missouri.
Okay, so as you can see, it was severe to extreme winter across a good part of the northern and central plains, I think you could just say the Mississippi River Valley from north to south, and a good part of the eastern US as well. So I see one site that set a record extreme. That would probably be, it's South Dakota. What is it, Watertown or something like that? And and another one over in western Wyoming there, and I don't know what site that is, I'm afraid. So yeah, this was a pretty, it was on the severe to extreme side. I can't say it was a bad winter. Sorry, Steve. I'm trying not to. I'm using my words.
Well, Barb, thank you very much for taking your time again today to do this. I have a request. I know you have special buttons there that you can push. And if you could just hold off on the snow till all our leaves come off the trees, and just have rain in the meantime here in Colorado, that would help us from a lot of broken limbs that we usually get.
I'm afraid I'm in marketing, not production.
Okay, well, I figured I'd give it a chance. Well, again, thanks for joining us. Again, pleasure having you with us today, and we look forward to more collaborations with you in the future. So folks, as we close out today's program, we want to let you know that our next Weather Talk webinar will be taking place in just 3 weeks. Yeah, they're coming up close together here. That'll be on Thursday, November the 5th. It will feature Joel Myers, the founder, CEO, chairman, and president of AccuWeather. And Joel will talk about the history of commercial sector, weather sector innovation, and challenges of the future. And I saw this presentation at this year's annual AMS conference, and you're in for a real treat. I think he did a great job with that, and we want to invite him here to share with the rest of our viewers out there. We'll have registration information on our website in the next few days. That'll be coming up. Before I forget, when signing off today, please take the survey that will pop up on your screen. Really appreciate that. So until we meet again, stay safe and stay healthy. This is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now. We'll see you soon.